Antimicrobial peptides have always been interesting to me for some reason. I think it's because they were first really found in frogs. They were called meganins when they were first found. There was a researcher somewhere in Texas that was doing ovarian research on Xenopus laevius, the aquatic frog that's kind of like the white mouse of the amphibian world. And what happened is they had a school class come through to tour the labs one day, and he was talking to some of the kids, which is something we all enjoy doing. And one of the little girls asked about his frogs. So he would do little microsurgery on them and then put them back in the tanks while he worked on the ovaries. So the little girl said, "Don't the frogs ever get an infection?" And it was like a bell went off for him. He was like, "I'd never thought of it because I was concentrating on the ovaries." So the female frogs were thrown back into tanks that were dirty, that were filled with a lot of bacteria, and yet they never seemed to get an infection. So he started doing research, and he found that the frog skin actually secretes antimicrobial peptides, which can punch holes in bacterial cells. But they had a lot more activities. They eventually found that many of these antimicrobial peptides are antiviral, antifungal, anti-cancer. Very small nanomolar concentrations of some of these antimicrobial peptides can reduce the size of a brain tumor by 95% in less than 24 hours. They're found in humans, and they're called defensins. Uh, in sharks, they're called squalamines, for the dogfish shark, Squala squalidae. So they have all these different names, but they're lumped together as antimicrobial peptides. And what they are peptides that are going to be attracted to negatively charged cells. Our cells have a overall neutral charge to them, but bacterial cells, fungal cells, cells that are cancerous, cells that are infected with intracellular parasites frequently have a slightly negative charge to them. They're producing more metabolic waste products, and these antimicrobial peptides will arrange themselves and punch holes in the cell surface of those cells that have something wrong with them. So it's really an interesting topic, and it's something that they're looking for ways of utilizing this to treat different kinds of patients. I always thought that it would be nice if we could find defensin-like molecules from organisms that live in salt water, like sea cucumbers or maybe even nudibranchs, which are the shellless snails. If we could find those, then we might be able to find a treatment for patients with cystic fibrosis. It wouldn't be a cure, but it would be a way, so if they get a lung infection, maybe they could inhale a diluted form of these antimicrobial peptides, and they could function in the higher salt concentrations that are found in the lungs of CF patients. So that's antimicrobial peptides in a quick nutshell.